Hello, hello! Welcome to the stream. David Snowpeck here from Snowpeck Games. I can see we've got Boss MB Gaming rocking out. Pretty basic looking character. Some shoulder pads, a beard. According to the little eyeball, it tells me that there are people watching. There are a number of other people here. If you want a character on the overlay, say something in chat. If you want your words to appear in the bubble on the overlay, you'll need to come over to Discord. But yeah, how's everybody doing? How's it going? Any word on your guys' projects? Playing anything cool? I've been for whatever reason playing GTA 5. I don't know why. I'm just like, it's not a game that I thought I would go back to, but it's just comforting. It's just comforting. Driving around a city, doing mindless shooting of people. All right. Yeah. Let me know how you guys have been doing, how your projects are going. Otherwise, I will jump into the description of the project we're going to be working on today. I am excited. I don't know if you guys are getting sick of working on this VR Voxel game for the last, like, I don't know how long it's been, like 4 streams or 5 streams. And the last 3 of them, we've been continuing to work on the same performance optimization, the meshing. But we're getting really close on it. I'm excited about where this is going next, and hopefully it will solve our performance woes and let me be able to start sending this game out to folks to playtest. Anyway, as no one is saying anything, I will go ahead and jump into the project introduction. So this is a VR Voxel Builder game. I'm targeting the Oculus Quest. There is going to be a desktop version. There already is a desktop version. We'll be using that largely in our development today. But let me really quickly show you how it looks like in VR. Hey, The Clean! Welcome to the stream! What kind of character did you get? Oh, you are the warrior of the stream today, The Clean. You got a big axe, beard, some sweet shoulder spikes in case you need to spike someone or something. I don't know what those are for. Probably decorative. Anyway, I'm going to put on the headset. I'm going to show you guys what the game looks like, largely for folks who have never been here before, if this is your first time. And yeah, then we will talk about the challenge we're trying to tackle, where we're at, what we're going to be working on today. So just give me a second to put on the headset. Double headset time. Just get through some menus here. Then I should be able to let you guys see what I am seeing through my left eye. Yes, cast. Cast? Is it working? It is working. Okay. Let me make this a little bit bigger. You can see it in OBS too, so we are good. So this was me testing out that things still worked before the stream. I think I'm actually going to clear this out. I'll do new. All right, so it is a VR Voxel Builder game, meaning you place some voxels and stuff. More of an art tool than a game, although there is going to be like a hangout in the worlds that you build mode. Maybe we'll put in some mini games. You can shoot your friends or something like that. But the thing that makes this unique, or at least interesting, is that the voxels that you build with, you can create out of smaller voxels. So here we are building a new voxel. Before I was making a flame, what you saw when I first loaded in. We can do that again. So I was just kind of putting a little base and some spiky kind of bits on it. In red, then we'll do a little orange coming out of the red. And then at the top, we'll put some yellow. Oops, don't want to go that high. Don't want to have this be multiple voxels big. Although actually that's fine. It can be tall. You're not really going to place anything above the flames anyway, right? Unless you want it to be on fire. So yeah, that's a bit of crappy fire. Let me put a little more orange over here. And then when you come out of the sort of creating voxel mode, I now have this as an option on my palette, and I can place as many of these things around. The idea being that you should be able to quickly switch between building the world and building the voxels out of which you are creating the world. The game is going to have multiplayer, online multiplayer. I'm hoping to start working on that soon. This performance crap has been taking way longer than I had expected it to. But yeah, so collaborative building and multiplayer, as well as, you know, the interaction mode where you're chilling and maybe shooting shotguns or something. I don't know. So that is the game. The problem we are tackling is that it doesn't take placing very many voxels for the frame rate to drop real low. Here, can we make it happen? Should we see if we can make it happen? We'll put a lot of these flames. That's a lot of flames, but it really actually isn't making the frame rate low right now. Maybe because the meshing is doing something, like it's not doing everything I want the meshing to do, but maybe it's doing enough that this is actually like kind of chill. Let's play some more voxels. Let's switch to the shape tool here and see if we can't make... Oh, frame rate's dropping. The frame rate's dropping. Oh, but now it's back to normal. Interesting. Well, I can't get it to happen. That's cool. That's awesome. Anyway, the meshing is incomplete. It can only mesh one type of voxel, not the two types of voxels. The two types being, we have these sort of primitives made out of... Ooh. Did you guys see those faces disappear? That's a meshing error there that we will need to address. But we have these two types of voxels made out of meshes, which is what these are too. These are primitive shapes. We only have a couple of shapes. And then we have the voxels that are made out of other voxels. And our meshing code can only mesh the one and not the other. So let me get the headset off here. See, a couple of new people have hopped in. We have Smoloki, or I guess one new person. How's it going? Cool character, please, please. What did you get, Smoloki? You got a braid and sort of like a toga top with some pants. Possibly wearing some lipstick. Hard to tell. Boss MB Gaming, there is no way I get burned out watching your streams. Every week I learn something new. Oh, awesome. Thank you. Thank you, Boss MB Gaming. That is really motivating to hear. At the end of the day, you're not pushing a lot of polys. Yeah. I mean, the goal of the meshing is to push even fewer polys, as few as we can get away with. There's actually like a balancing act, which I don't know if Phil Du is going to come today, but he and I have been talking a lot about meshing in VR Voxel games, because he is also making a VR Voxel game, not in Godot. I think he's implementing it in C or C++. But there's a balance between making your meshing really, really good to reduce the number of polys and vertices and all of that, versus getting it done quickly, right? Because you can make a really complex algorithm to really, really cut down the number of polys in your mesh, but that takes a long time. And so you have to strike this sort of like middle balance, because in the end, the goal is to do this fast, right? It doesn't help that you've reduced the number of vertices super duper low if it takes you like crazy long to do it. Smeloki is fine with his toga-wearing Viking. But yeah, I honestly I am surprised that that I couldn't get it to slow down. It used to be so easy to just get the performance to go way low, but yeah. So we have been implementing meshing in this mesh optimizer class, and it is relatively simple. I mean, it's getting more and more complex, but basically it's just looping over all of the voxels, finding out what the neighbors are of the particular voxel we are adding to the mesh, and then using some logic to determine which faces from that current voxel we are going to copy into the mesh. So, you know, we're finding the neighbors, we're checking which faces are there, and then we are copying the faces. This is currently specific to the one voxel type, like I was already talking about. So the way that this works is there's a bunch of types of voxels There's like a different resource class for each one. We have the mesh voxel type, which is a voxel that is just composed of a mesh. We have the voxel object voxel type. Let me find where all this code is living at. Yeah, so voxel object voxel type. This is a voxel made up of smaller voxels. And then we have this scene voxel type, which we're not using for anything right now. But if we want to have like game objects with code attached to them to exist in the world, I want to be able to create new voxel types that are scenes. So yeah, then the mesh optimizer is looping over all of the voxels. If it is a type that it can optimize, like here, if voxel type is mesh voxel type, it will add it to the mesh. If it can't, it'll add it to this list of unoptimized voxels, which will just get instanced individually. Hey, Phil Do! I was just talking about you. Thanks for coming to the stream. Ooh, and we have another person on, KT Wondersheep. Some particularly stupid people choose Godot and C++, and Godot for it that whistles innocently. Yeah, I mean, I do a lot of C++ and Godot as well. This project, in fact, once I figure out really well how I want everything to work, I'm definitely going to take this performance critical code like this mesh optimizer and put it in C++. It's just much easier to figure out what the heck everything is in GDScript because I can iterate really fast. So, Phil, to answer your question, I didn't look at what your character was though. KD Wondersheep, also getting a pretty strong looking character with the fro and the shoulders. Phil Do is an orc with the strap. And another fro. Everyone's looking good. KT Wondersheep, are you 3 or 4 enjoying GD extension quite a lot? Yeah, so this project is in Godot 3 because well, I mean, for a lot of reasons, but one of them being that the main target of this project is the Oculus Quest, which is not supported in Godot 4 yet. Might not be until Godot 4.1. I mean, it all depends on how Bastian's work goes and when the beta comes and all that stuff. But also just... I plan to release this project relatively soon, so I'm doing it in Godot 3. I do love Godot 4 and GD extension. I made a GD extension last week. It was great. I've never liked GD native, but I do like making Godot modules. That's a really nice developer experience. Of course, to make a Godot module, you have to recompile all of Godot, whereas GD native, you just compile like a DLL or an SO or dylib or whatever the macOS thing is, and you load that in. Well, GD extension provides the great developer experience of making a Godot module, but you just make a DLL or an SO or whatever to load in. So it's kind of like the best of both worlds. It's really, really cool. I'm excited about being able to use that more. Yeah. So let's talk about how our current meshing of these mesh voxel types work and how I want to extend this to also mesh the voxel object voxel types. I actually had like kind of an existential crisis about the design of this over the last 2 days. And Phil, you were really helpful in talking through some of this. I went through like a million new designs in my head because this is getting kind of complicated. And I was like, well, we already have this code for meshing these primitive voxels. Like the big voxels are just more of the primitive voxels. Maybe we could do it all in the small grid. I know you suggested that, Phil, but then I was, I don't know, worried like that's going to make for us to have really, really small chunks. So I remember you said, Phil, that you're doing 32 by 32 by 32 chunks. On the small grid, that is just 1 meter by 1 meter by 1 meter. That's a really small chunk, right? If we do it on the small grid. If we do it on the big grid, 32 by 32 by 32 is quite large. You know, it's 32 meters by 32 meters by 32 meters. Or no, actually, on the big grid, a voxel is 1/4 meter. So I guess that's mathematics 8. Is that 8 meters? 8 meters by 8 meters by 8 meters? Anyway, I ended up kind of abandoning that. Maybe I'll go back to it. We'll see how this goes. Where what I want to try to do is make the voxel object voxel types be sort of like when the mesh optimizer runs on them, it's going to kind of reduce it to a mesh and the same kind of data that we have for doing the mesh voxel types. So the mesh voxel types have all this like kind of extra data that will explain how to do the meshing. So it has the mesh, of course, and then it has some bit flags saying which sides of this voxel type are solid, so that it can decide, you know, that it can exclude faces from other voxels that are touching it, since our voxels aren't all uniform cubes. They have different sizes and shapes. and this face exclusions dictionary, which is basically a list of faces that can be excluded and some bit masks to say we can exclude this face when we have neighbors on these sides with solid sides, right? So the idea is the mesh optimizer is going to take a voxel object voxel type, optimize it into a single mesh, and then kind of like generate this same data, and then we will be able to mesh them the same way, if that makes sense. I hope that makes sense. Oh, Phil says, actually, my chunks are 16 by 16 by 16. Yeah, cool. That would be even less good in my situation, because I think things would just get too small. But I don't know. I mean, I don't know what size my chunks are going to be. I haven't gotten to the chunking part, but I think that will actually be just part of the mesh optimizer as well. The mesh optimizer will look at the whole voxel object, because the voxel objects aren't actually that big in my case. We're not building Minecraft. We're not building an endless procedural world. We're saying, like, you build a house, right? That's what this game is. You're creating a structure within which to hang out or do something. So I think we can look at the whole, the voxels for the whole object, and then we can break that up into pieces in the mesh optimizer, and the mesh optimizer is just going to spit out a bunch of meshes rather than just a single mesh, and that's how we're going to do chunking. So 2 to the 15, that's like 30-something thousand voxels. I guess I could push the quest to its limit. Hey, Adrian, welcome to the stream. What kind of character did you get? Where are you, Adrian? Oh, there you are. A shirtless guy with the shoulder pads and kind of a Hulk Hogan mustache. I mean, I think you're definitely a professional wrestler. I think that's what you are, Adrian. So, let's get down to this. There's one thing that I think is missing from the kind of metadata that we have about the mesh voxel types that I think we'll need in order to kind of like reduce a voxel object voxel type into the same metadata, and that is that we don't know which faces are edge faces. We have this face exclusions thing, which works great when deciding which faces to keep when we're meshing something on the small grid, but we need to be able to generate this face exclusions for the voxels made out of the smaller voxels, and to do that, I think we need to know which faces are edge faces. So we're going to add a new dictionary. I think it makes sense as a dictionary, at least for now, at least until we C++ size this. Which will be, I guess, edge faces. And we want to store, I guess, an entry for each edge. So we have this enum here with the sides. So we're going to say, like, the front edge, and then I think a list of face indexes. And do we want that to be a list, or do we want that to be another dictionary for fast lookup? I think it's okay as a list. A particular edge is not going to have that many faces. In the case of, well, I mean, it could. We'll start with a list. We'll start with a list and see what happens. So I'm just make a little note here for myself that this is edge faces. Say like side equals face index, just so I remember what that is. And we are going to set that on our primitive voxels. The primitive voxels on the small grid are created by a script. This create primitive voxel library. And we kind of already have this data in the face exclusions. But here's what I'm thinking, actually. We will mark the edge voxels, we'll mark the edge faces, and those will imply a particular face exclusion. So we can get away with not specifying the face exclusions for edge faces, if that makes sense. Is any of this making sense? Let me know if this is just gibberish, if my explanation of how I'm trying to address this problem makes any sense, or if it doesn't make any sense. That's the most important. Tell me if it doesn't make any sense, and I can explain it. better, hopefully, with some pictures or something. Okay, so we're going to look at the face exclusion data, and we are going to kind of convert it to a list of edge faces. So before we were saying if the front flag is set, we can exclude face 0 and 1, and now we're going to sort of just rearrange this and say the front face is face 0, or the front side, get my terminology right, the front side is composed of face 0 and 1. I don't have to do front twice. 2 and 3. And maybe I'll even keep these exclusion flags for now, or face exclusions, until I'm confident that we can actually eliminate those. So the right is made up of face 4 and 5. Left is made of face 6 and 7. Just in general, I find like a lot of programming problems come down to data structures, like especially the more low level that you're working. Like whenever I'm doing anything in assembly, which I don't do a lot, but I enjoy, I feel like the solution is never an algorithm. The solution is always a data structure. I mean, maybe not never. Never is probably not the right word. It's 90% data structures and like 10% algorithms. Okay, we'll start with just trying to do this for the one voxel type, which is our primitive cube on the small grid. And I guess we will, to test this, we'll make a new voxel that's just like made up of all of these primitive smaller cubes and kind of see what we get. We also might need to like write some unit tests, because the sophistication of this is getting to a point that it might be easier to test like individual methods rather than, you know, going into the game and placing stuff and trying to see like, does this look like it's working? But we'll see. All right, so let's just try and see if we can replace our exclusion mask, face exclusion stuff with those sides and see if that makes sense. Or maybe what we'll have to do is like look at those, what is it called again? Look at the edge faces and then generate the face exclusions. I'm not sure. Okay, so here we're looping over the faces. We are seeing if we have an exclusion. Then we get the exclusion mask, and we rotate it. We have to rotate the mask for the rotation of this particular voxel, since we can freely rotate them. And then this is the binary logic that I drew this picture for last week. So we check if this face should be excluded and if the neighbor faces are solid, which is something we didn't have last week. I realized it was missing. In the in-between time. And if so, we don't copy the face. So how can we add in this idea of edge faces? So we're getting the face. So we could say if this face, so we would check if this face is in a particular edge. And I think we probably want the face exclusions to override the edge stuff. Hey Zen Matio! Can Godot make augmented reality games? Yes, it can, but the support for that is definitely worse than VR. So I'm the maintainer of the WebXR module in Godot, and it does support AR in WebXR, but it's not very good. Like, and this is just my fault for not having gone and implemented these things, but they're like, there's no anchors. which are something you usually want in AR. So like there's really weak support in WebXR. Then in not WebXR, AR Core, AR Kit. I always forget which one of those is Apple and which one of those is Google. But the Apple one is apparently still working. But you have to like compile some stuff to use it. And the Google one, there is code to do it, but you have to compile some code and you have to like apply a bunch of patches to Godot in order to make it work. So yes-ish if you are motivated, or if you want to use WebXR and like don't care that there are no anchors or like other things that you probably want in an AR game. But there is, we will say, some weak AR support, and really the reason is Core is Google, AR Core is Google, and AR Kit is Apple. The reason that the support is not that good is that there's just nobody motivated to make it better. Bastian wrote the AR Core and AR Kit stuff, but he really isn't into AR. He doesn't care that much. I maintain the WebXR module, but like I don't really care that much about AR either. So what we need is like a contributor to show up to the Godot project who's like really hyper into AR, who wants to put in the work to make it happen. Because I know if someone did the work and made PRs, pull requests against Godot, that they would probably get merged. It just needs that motivated individual or individuals to go in and make this stuff good. Will you be participating in the GMTK Jam today? Nope. No. I did a game jam like 2 months ago. I can't do them too often. It's just too draining on me physically. But the GMTK Jam is awesome. I'm looking forward to seeing what games come out of that. Usually like just an enormous number of people participate, and I love game jams. But no, I just don't have the stamina to do another one. Not right now. All right, so we're gonna check the face exclusions, and then if there is no face exclusion, we are going to check if this face is an edge face. How do we check that? I don't think there's a fast way to check that. We'd have to loop through every edge, because this loop is based on faces. Okay, so maybe the thing is that we automatically generate face exclusions from the edge faces. And how would that work? When would that happen? So we have these face exclusions, which would be specified in the resource. So we have these face edges. Maybe we like have a method here that combines these two things and then passes it back up. That might be the way to go. Let me look at what this looks like again. So we want to know which faces are for a particular edge. We want to be able to say, hey, give me the faces. Okay, so we're meshing, we're going along. We have this voxel. It is on the edge of our kind of bounds that we're working within, so like in a voxel object, voxel type. And we want to be able to say, hey, this face that we just copied in is an edge face, so that we can generate a face exclusion for it. Now, what is the ideal data structure for that? So we're going to have the face. We're going to have the face, and we want to know that it's an edge face. Maybe we don't need this separate data. Maybe there's a way to derive this from here? Well, not really, though. Because we have these other faces that are like real weird. So this is the half voxel. These first two faces are like the one that's kind of hovering in the middle, and it is not an edge face, so it would not be recorded. Okay, I think what I'm gonna do is I'm just gonna stop doing this edge faces thing, and I'm gonna try to write the code that I think needs it, and then when that is working or not working, we will see if we need to add some data. I can't seem to get your code to work. Maybe it can be a little big? I'm not sure what you mean, Zen Mateo. Which code? Which code are you using? I have a lot of code out there on the interwebs. Okay, so we're sticking with the face exclusions thing. But here, we need to say this new face that we created, is it on the edge of the bounds of what we are optimizing? And if so, it needs to be put into the face exclusion list. Does that make sense? So, okay, taking another step back, what we are trying to do here is we can do this in 2D. We have our primitive voxels. And let's say this is the whole thing. That's the whole thing. We're filling in all of these spaces except this one. So the voxel type would be here. These two are the edge voxels, or not edge voxels, edge faces. So then if we put another one here, let's say a fully square one, we would say, okay, because this side is fully covered, we need to exclude these faces. And to do that, we need to know that these faces will get excluded if they are on the right. How can we know that? Solid side voxels. I don't even know what that's for. Okay, let's just think about face exclusions here. How to update face exclusions. So this face has its own like exclusion mask, which we had up here. And maybe we only care about this up here. So this other branch down here is if we have no face exclusions. So there's no condition under which this face would ever be excluded. And so what we care about is in here, right? So we've just copied a new face in. We know what its face exclusions are. We need to produce a new face exclusions for the overall object with the new face index. What should it equal? Phil do. Is there static bounds of sub-voxels per voxel? Like one voxel is 8 by 8 by 8 sub-voxels? Yes. So that's what I'm imagining this bounds is telling the mesh optimizer, like, this is the bounds of the thing that we're optimizing, which would be the bounds of the voxel thing. Man, it's so hard to talk about this because of the big grid and the small grid. But yeah, like this variable would be telling us how big of a space. So this would contain 8 by 8 by 8 if we're dealing with an 8 by 8 by 8. size, which of course we aren't always. I made this so complicated for myself. The voxels that you build on the small grid can actually be like any kind of size, right? They can take up any number of voxel spaces on the big grid. Because I wanted to be able to build complex objects on the small grid, like I could make a laptop computer, which might need a 2 by 4 by 2 or something space. But we will know that when we're optimizing it, because this is recorded on the voxel type, and we can pass it in. So okay, we know what its original exclusion mask. Okay, so what we need to know is this voxel that we just placed on an edge? And which edge, right? Or do we care which edge? Back to the drawings. Okay, so we are placing, we have this voxel here, or let's use my original picture. So we're copying this particular face. And we need to know what its face exclusions should be. We know what its original face exclusions are, which are this and this. Or no, not that. This single face just has one face exclusion, which is here, the right side. So because we are placing this particular voxel on the right edge of its parent voxel thing, we can copy this face exclusion into the parent. But we can only do that if this is on the right edge. And thinking sort of generally, that means we can copy the face exclusions for any face or for the edges that this voxel is on. So if this voxel was on the left and top edge, that means we could copy any left or top face exclusion. So what we need in the end is like a mask that represents which faces this voxel is touching, and then we need to and that mask. So what can we call that? That would be like bounds mask. I don't know why I'm writing this out. I actually have a drawing tablet right over here, but it's being used to show the little characters. So I can't just pick up my pen and like draw. That would be much nicer. But anyway, so we have this bounds mask, and then we can take the bounds mask and multiply it by, not multiply it, and it. Ooh, we get to draw an ampersand. That's not an ampersand. That's like an S. With its original face exclusions, and then that would be the face exclusions for this face, I think, right? So what we need to know is we need to be able to get bounds mask equals get voxel bounds mask. We'll make a voxel bound mask. We'll make a method for this, and this needs to take the voxel's position and orientation. And actually we can put that up here, because this is for the whole voxel. Okay, so bounds mask takes the position and the orientation. And then here we can say the face exclusion is equal to the bounds mask and its original face exclusions, which is exclusion mask here. Okay, so this exclusion mask takes into account the rotation, which is good. We need it to. This bounds mask doesn't actually need to take into account the rotation, does it? Okay, so we have the voxel that we're working on right now could be rotated in any kind of way, but all we care is which edges of its parent is it sitting on. So maybe it doesn't need the orientation. Maybe it just needs the position. Where's the position coming from? And what is this position? Is this position the world position, or is this position the voxel position within the grid? Okay, this position is a world position. That doesn't help us. We don't want that. So I guess up here, we're going to figure out the bounds mask. And we're going to pass it in. So we need to say, like, if bounds does not equal null, because we're going to sometimes not have a bounds, like when we're meshing the world or whatever. If we have a bounds mask 0, then here we will do this bounds mask position, and then we'll pass this into here. So we're giving the voxel type, the surface tool, the world position, the neighbors, the config, and the bounds mask. I think that order makes some kind of sense. Let's go here. Bounds mask. Okay. I think this is correct, assuming we can actually get this bounds mask. Is there a static bound of voxels per voxel? Okay, we already talked about that. It's almost like you are chunking. Yeah, we are basically chunking. The way I call interchunk faces is my chunks are stored padded. So an 18 by 18 array, then on edits, I make sure to copy all edits into other chunks padding. Then I can just pass a single padded chunk into the mesher and it has access to all of the edge voxels of adjacent chunks in one place. This would be more complex in your case because of your arbitrary chunk bounds, but I figured I'd throw it out there as an example strategy to be aware of. Yeah, that would be really nice because ultimately we do want to do like the same logic that we have for meshing the small voxels, but only on the edges. But I think, I don't know, I think this approach can pull it off. Maybe it can't, and maybe I'll have to, come into a thing where maybe we place, an extra set on the edge and then, like, I don't know, delete that set or something. But yeah, this is a weird kind of case because we are not, these aren't just, like, chunks are unique, right? You have all of these chunks next to each other, they are their own thing. These voxels made of voxels that we're placing are not unique. They are the same thing stamped out a bajillion times. So I don't necessarily want to have to address every single voxel within those. I just want to somehow address the edge ones. And I think this could get us there. We'll find out. Okay, so now we need to make this get, what was it called? Get voxel bounds mask, voxel bounds mask, and it's going to take just a position, and it's going to return an integer, and let me write a little bit of documentation for myself so I remember what this does. So this is gets a mask representing the sides of the bounds that this voxel position is touching. So our bounds are going to be in like voxel coordinates. So we'll say like if pose x equals 0, hang on, then we'll do var bounds mask if the x position of our voxel is 0, that means we are touching the left side, because of the way that we orient our voxels is the z goes this way, from the 0th out towards us. Z0 is back, which means that x goes this way, or probably the reverse to you guys because you're in mirror world, and then y is of course up. So if we are x0, that means we are touching the left side. So that's voxel type side flag left. If pose x, y equals 0, that means we are touching the bottom. Flag bottom. If pose z equals 0, that means we are touching the back. Or actually not 0, because what if we give an arbitrary value in the bounds? We never will, but I guess I'd like to account for that. So we'll look up the docs for A, B, B, and C, what these variables are called. So I guess that's position, and then end we're dealing with here. So if x equals, we'll say bounds position x, bounds position y, bounds position z, and then do if pose x equals inclusive and exclusive sets always throw me for a loop. Okay, so if our size is 1, 1, 1, then end would be also 1, 1, 1, right? So it's an inclusive set, which means we can say if x bounds equals end x bounds mask. We'll add the voxel library, voxel type side flag. Would touch right. I think maybe I'll put the x's near each other and the y's near each other. Seems easier to look at that way. End equals top. If z equals nz, that is front. And we need to return this bounds mask in the end. Okay. Is this like even remotely correct? So we're copying the face. We take its face exclusions and it with the edges that it is touching, and that is the exclusions for the whole thing. And we have all these interfaces, which probably should have face exclusions for when the voxel is completely surrounded. But maybe we can handle that globally without having to just like fill up this face exclusions dictionary with every single face that we're putting in here. This would be more complex in your case. Oh, okay. Yeah, that Phil already said that. Sorry. I thought it was a new comment. Ooh, Pixie's got the jester clothes. I missed your character when you first came in here. Is anyone else I missed? No, it looks just like Pixie. Or did I see what Zen Mateo looked like? I also missed Zen Mateo, an orc with some braids. How are we doing on orcs versus humans here? 3 orcs? What is that, 5 humans? Oh, the humans are winning again. Anyway, let's try this. Let's see if this actually works. We have to do a bunch of work to integrate it into the other stuff. So now we have the mesh optimizer will do this collecting face exclusions thing. Oh, and we also need to figure out if we have a solid side. Solid sides. So if one side is completely covered, oh, how are we going to figure that out? Let's address that later. Let's deal with this one now. We'll test with a solid primitive voxel against one of these more complex voxels of voxels, so we don't have to deal with this yet. So we need to have the mesh optimizer gather this information and then set it on the voxel object voxel type. And when will we do that? Well, when we first create the voxel, when we're creating this voxel object voxel type, let me just search in the code for where that is. Voxel type. Builder manager may be creating it. No. Is the palette page creating it? That'd be kind of funny. Yeah, probably UI elements should not be responsible for creating new voxel types. They should probably be somewhere else. But it's here right now, so we're gonna do it here right now. So when the create button is pressed, we're creating the new type, throwing it into here. Then when we press the back button, we actually probably shouldn't create the type initially. We should probably create the type when we're done, right? So we press the create button. Creating the new voxel object makes sense, but creating the new type probably doesn't make sense until we're done. Well, we'll keep it this way for now. Where's the back button? When does the back button get pressed? I think that is somewhere else in the palette. Palette, where are you? It's called voxel palette. Let's look at the structure here, the directory structure. It is this, palette.gd. Okay, so here is what we do when we're going back. If we are targeting a block, then we change the target. You know, this is the point. This is the point where it should get created, I think. But we're like storing the target type for some reason. Do we refactor this now or do we just carry on? Let's just carry on. I'll put something on the to-do to refactor it. Let's say refactor block creation so that block new voxel type isn't created until after we exit editing the block. So I was here. Okay, so if it's not empty, then hey, Coop Myers, welcome to the stream. What kind of character did you get? Oh, someone's stuck at the bottom. Coop Myers got a braided fellow with a green shirt, looking good. And here we will load up a mesh optimizer, which of course we're gonna have to include this class in here, mesh optimizer. So we'll make a new mesh optimizer, and it's going to take the voxel object, editing voxel object here, and we're going to optimize it, which we can say editing voxel type. Do we have the editing voxel type? We do not. We need to get the voxel type. Or we'll say editing voxel type equals builder manager. Wait, do we have it on the builder manager? Let me just go see if we already have this. We don't need to request it again from the library. Go over to builder manager. We have target type. Okay, cool. So we can grab that. We were in the palette, I guess. Setting voxel type is builder manager target type. So we run the mesh optimizer, and then we can set some stuff. So there should be like an optimized mesh variable. We can set mesh optimizer, optimize, and then there's all of the other data, like the exclusion, face exclusions. We'll also grab off the mesh optimizer, face exclusions. Is there any other data we need to grab? This edge faces thing we're not doing. The solid sides we will need to have. Wait, we're missing like a whole thing here. So this, what we're setting up with these face exclusions will totally work for meshing against like another primitive voxel, but it won't work for meshing against another one of these complex voxels. God, this is why I almost decided to switch to doing all of the meshing on the small grid. We could sort of fake mesh on the small grid if we know which voxels these come from, right? Like, if we can associate these faces with the original faces from the voxel that they came from, then we can kind of do where we go on the edge and look at the next edge over. Why is this so hard? So how would that look if we were keeping that data? I think that's why I had the whole edge faces thing going, because we would say, no, that doesn't solve the problem either. Okay, so how would this look? If we are trying to keep track of this face that we are adding is actually a particular face on a different voxel. I guess we would keep this face ID as the index, the new face ID, and we only care for faces that are on an edge. So that are like excludable. So okay, so this would be like new face bounds equals bounds mask and exclusion mask. So that's already right. And we would need to say if new face bounds, if it has anything in it, if it's not 0, meaning this face is excludable and it exists on an edge, then we would want to record so this would be like, I don't know, edge faces, new face index equals the position of this voxel, which we don't have at this point because it's not passed in. Voxel pose, we'll just write that for now, and the original face. Do we need to know the original face? Hang on. Okay, so we need to know. We basically just need to know its position, right? Oh, this isn't right again, because okay, we don't want to know the ones. Okay, what's the problem we're trying to solve? Back to the drawing board. The problem is we have this really awkward shaped voxel thing here, which is touching another really awkward shaped voxel thing here. And we need to know that these faces on both of these can be excluded. And how do we know that? We are looping over each face, and we are looking up this position here. So we'll have the face index, whatever that is, we'll call it X. And we need to be able to say, this face, check something on this other thing. Yes or no. What we want to check is if this voxel here, if this voxel has a solid face here. That's what we want to check. And so then this voxel needs a list of, or no, it doesn't need a list of anything. We can already go through its array of voxels. We just need to be able to know that this face comes from this position on this object. So what we need is the face connected to a position, right? So we need to connect the face ID to a position, and we only care about the voxels on the edge and the faces on the edge. And so how do we know that this face is on an edge? Okay, so we know that this face, we know that this voxel is on an edge because of the bounds mask. Right? So if bounds mask, this voxel is on an edge. This face that we're adding, how do we know that it's on an edge? I guess because this is marked as a solid side, right? So if we go to the mesh voxel type, it has this solid sides. So if this face is on a solid side, how do we know that this face is on a solid side? We don't, because we don't have these edge faces. Let me write some pseudocode or just comments in here. So if this voxel is on an edge and this face is solid, or no, and this face is on an edge, and this face is on a solid edge, then we want to map from its face index to its voxel position, I think. Voxel is on an edge, its face is on a solid edge. So if this voxel is on an edge, its face is on a solid edge, that means this is a solid edge face. That means this is an edge face. If it's an edge face, then we want to map from its face index to its voxel position. So the mesh optimizer can, well, whatever. But the so we'll leave off for now. So we need a way to check if this face is on a solid edge. And to do that, or is it even need to be on a solid edge? I think so. I think it needs to be on a solid edge. So then this edge faces comes into play. What does that need to look like in order to do the lookup we need to do? So this voxel is on an edge. We know how to check that. And this face is on a solid edge. So we need to know what edge this face is on. And that would be mapping the face index to a side. So then we're back to like the first thing I was trying to do on the stream, where I couldn't remember why we needed it, but I think this is why we need it. So then if this face is on a solid edge, that means this is an edge face. So we need to know the face edge. What edge are we actually on with this face? And that will be the bounds mask, and if it's an edge face. Okay, so we need to say like if if voxel type edge faces has this face, then the edge face is the bounds mask, and the value of edge faces, right? Because, like, let's say the bounds mask says right, and then the edge face for this particular face is left. We don't care. It needs to also be right. So, and right. And the right side of this voxel needs to be solid. So we need to say voxel type solid sides. And this will tell us the edge that this face is on. Now what the heck do we do with that? Do we do anything with that? Do we need to keep that? Or can we just say that this position is a solid subvoxel, right? This position is a solid subvoxel if this is true. If this is true, then this subvoxel is solid. And so now we need to record like solid subvoxels. Yeah, solid side voxels. That's what this is. But they're only solid in like a particular direction, right? Like what if it's on a corner? So we do need to keep track of like what direction it's solid in, right? Or wait, so a face is only solid in a particular direction. Oh, this is so complicated. Ooh. I'm gonna take a break and look at chat. Hey, Coop Myers. Coop Myers, I want to thank you for the rollback netcode and SG Physics 2D. You are welcome. Thanks for using them, and thanks for letting me know that you're using them and finding them very convenient. That's super motivating. That is super motivating to hear people having good experiences with open source stuff that I release. That was a nice break, Coop Myers. Nice break from this frustrating stuff. So Coop Myers, what kind of character did you get? You got kind of like looks like one of those like 18th century wigs, like the founding fathers, as they're called, wore all those 18th century people. Okay, so again, the question is, what do we need to record? What do we need to record here? So we are able to determine, if we have this edge faces data, that we are on an edge, that this face is an edge face, a solid edge face. Okay, so if this voxel is on an edge, and this face is on a solid edge, this means it's an edge face. If it's an edge face, then we want to map from its face index to its voxel position. Okay, let's map that. Let's map that. I don't entirely understand. When I wrote this comment, when I wrote this comment 5 minutes ago, I had a better understanding of what I wanted to use that for. But okay, so we'll say solid edge faces new face index equals voxel position. And that's not going to work because we don't have all that data. We'll need to pass it in. So up here, we need to pass in the voxel position and the world position. Let's go add that down here. voxel pose vector 3. Then we have the world pose, all this other stuff. And we don't have a place. Ooh, bounds mask. Typo there. And then the solid edge faces we need to actually store underneath these giant lookup tables. So solid sides var solid edge faces. This is a dictionary. Read-only dictionary. Do a little dance here. And I'm going to record what this looks like. Solid edge faces. So this is face index equals vector position. Just a little comment so I know what the heck I'm doing. Okay. So we gathered this data. It's being gathered here. Then we want to store it on the voxel object voxel type, which I think is what this was intended to be, this solid side voxels, which we're going to rename to match the variable here, which is solid edge faces. Solid edge faces. Just trying to think through this a little bit in my head. Sorry for the silent pause there. Okay, so we gathered this data. We want to put it on the voxel object voxel type, which we were doing back in the palette, which is the wrong place, but it's where we're doing it. So this is solid edge faces equals solid edge faces. Also, we need to actually store this data, the original data that we just added. So this edge faces, we need to store that on the voxel types themselves. So we're going to go back to our create primitive voxel library. This cube voxel. Hey, what's going on here? There we go. This face exclusions actually is exactly what we want for the edge faces. So maybe this is how we can have how we can omit the face exclusions in the case where we're defining an edge face. So let me go back to the mesh optimizer. Earlier on, I said I didn't know how to do this, but I think this makes sense. So we say what we want is an exclusion mask. So var exclusion mask equal, well, okay, we'll say exclusion mask starts out at 0. Hey, Krzysztof Jachna, cześć! Welcome to the stream. What kind of character did you get, Krzysztof? Where are you at? Did you not get a character? The overlay may be broken. Because I don't see you on here. I don't see you on here, Krzysztof. We can go look in the, see if it says we got disconnected in the logs here. Chat connection closed. There's a button I can hit to potentially reopen the chat connection. I believe that is the backtick. Let me try saying something. Test. Where's my character? Oh no, the overlay's busted. The overlay's busted. I'm sorry, everyone. I'll just restart it. It sucks that the button that I added to fix this problem didn't actually work. Oh, and then there's an error. Object was freed while signals were being emitted from it. That's interesting. So maybe that's why my button doesn't work, because we have this other error here. I'm going to copy paste this and put it somewhere so I can come back later and fix the stream tools thing. Anything to distract me from trying to work through this voxel meshing problem. Fix issue when chat connection is lost. Copy paste you. No, that didn't work. There we go. Okay, let's restart the overlay. By the way, I didn't mention it this stream at all, I don't think, but this overlay is a Godot game. The source code is up on my GitLab if anyone is interested in using it for their own purposes. Overlay test. Try it again, Boss MB. Hopefully it'll come through now. I'll do my own test here. Second test. Hey, should be working again. If you want to get a character back, hop in there, say something. Okay. So the exclusion mask. We get the exclusion mask in one of two ways. We say if, or actually, we could do something like voxel type face exclusions. We'll let face exclusions take priority over edge faces in case we want to have some complex rules. Edge faces. All right, hang on. Face exclusions get face. The default will then be voxel type edge faces get face, otherwise 0. And then we'll say if exclusion mask does not equal 0. And then of course we have to rotate it. Sign value does not have a time. Okay, yep, because I'm doing all this dictionary stuff. So int. Okay, so this way we will sort of derive the face exclusion from the edge faces if there is no face exclusion set. And then here we can get rid of this mess. How are we doing on time? We're doing okay. What kind of characters we get? Boss MB Gaming got a dude in a robe with a stash. I'm gonna guess you're a monk. I'm gonna say you're a monk. Smaloki got a knight. I think that looks like a kind of knight helmet with a shield. I'm going to presume that your sword is in a sheath hidden behind the shield, because what knight wouldn't have a sword, right? Oh, and I'm pretty armored up too. We're doing all right. We're doing all right. All right. So this one type should be set. Should we bother going through the rest of the types? I think so, actually. So we can say half voxel type. This is the one where it's like sliced down the half, so it's still like a box shape, but just half as deep. So we'll say edge faces equals, and we can copy most of these. So these are all edge faces, and then it's that first two that are not. I think those are the diagonal, or not diagonal, the one that's set back. So we'll do the same thing here. Diagonal sliced voxel type, we'll say edge faces. And again, these are all edge faces, and the first two, that is the diagonal slice. And then this one, the mini cube, only has one edge face, that being the back face. Okay. And we need to regenerate this, so I think I actually made a task for it in VS Code. On task, build primitive mesh library, go, do it. All right, should have done it, hope it did it. Let's check git status to see if it did. Wrong button. It did. Let's go take a look just in the resource. Yeah. Looks like all the things happened there. Okay, so now our data on the small grid has the edge faces. Oh, there's the one more on the big grid, the one primitive that exists on the big grid that's defined in Builder Manager. We'll go fix that one up too, just because I'm going to forget about it later if I save it for later. Oh, edge faces. Okay. Ooh, and I made a constant for that later. Voxel type side flag all. Okay. The data has it. Sweet. Our mesh optimizer is using it, and are we in a place where we can test this? So mesh optimizer. I'm going to turn these from to-dos to just voxel position, so we can look it up later when meshing this, when meshing the optimized mesh with another optimized mesh. Okay, so we build something on the small grid. It should get optimized and then have some of the metadata set. We're still missing one piece of metadata that I don't really know how to build up. That being the solid faces. So we'll need to go check all of the voxels on all of the edges to see if they are solid. Yo, Daniel8757, welcome to the stream. You got a pretty plain looking dude. You could be another monk, perhaps. Maybe you and Boss MB Gaming are rocking out in the same monastery, and me and Smoloki are knights somewhere, garrisoned somewhere. Okay. We're building up the data. It's not all the data we need, but let's test that this is doing something close to right. There's one more change I think I want to make, which is in the voxel object voxel type, we are currently considering these unoptimized voxels, which means they get created this way. I want to say if we have an optimized mesh, just use the optimized mesh. If no, okay. And this makes a voxel object instance. Okay, so we need to say if optimized mesh, then we are going to do something closer to what the mesh voxel type does, which is this. Man, this is a lot of stuff. Maybe what we'll do is we'll just make like a fake a mesh voxel type equals mesh voxel type new, and we'll say mesh voxel type mesh equals our optimized mesh, and then we will return mesh voxel type create node voxel library config. Okay. Sorry if that confused you, Daniel. But yeah, every person who says something in chat gets a character on the overlay. This overlay, like I just said a couple minutes ago, by the way, is a Godot game that we made on stream last summer. The code is open source on my GitLab if anyone is interested. All right, let's test this and see how horribly it crashes. That is what we will do. So we're going to test the desktop version, so I don't have to put on the headset, and it crashed right away. So this is in add mesh voxel, and the mesh optimizer. I should have ran this in from VS Code. Let me actually run it from VS Code so we can get a nicer debugger there. Bam. Okay, so this took us to the right place. Rotate sides. Oh, okay, because we're not, yeah. This should have been replaced with the new local variable we made for it, exclusion mask. Bam. Let's try again. All right, I can place some stuff. Nothing that interesting is happening because this, oh, and we got to set the bounds. It won't do our new stuff if we don't set a bounds. So that is over in Builder Manager. No, it was in the palette. In the, what is happening? Did I accidentally switch to QWERTY? I accidentally switched to QWERTY. Okay, back on Dvorak. The way the way it was intended to be. When we are doing the mesh optimizer, we need to set a bounds, which in this case is the grid size of the when does the grid size get set? So we're building this thing up. We need to set its bounds to determine what things are on edges. The voxel object type. Where does its grid size get set? Does it happen just like automatically as we're going, like in the block editor? Grid size. Okay. Okay, so yeah, as it's going, as we make the voxel bigger or smaller, the grid size changes. And so we can grab the grid size straight from the target type, which is cool. So we can say our bounds are editing voxel type grid size. So this would be the number of big grid units it takes. So we need to multiply that by the number of small grid units that are within the big grid. Do we have a constant for that somewhere? I mean, it's 8. I know the answer is 8. But if we have a constant for it, I would like to use it. Okay, we're just going to multiply by 8. Okay, so that should give us... Oh, and this actually isn't the right bounds. Ah, okay. var. We'll say size. So, okay, so this is the size on an AABB, which we're going to have start at... Can I do position and size? We'll have to see. We'll go look at the docs on AABB again. Right, so position and size, beautiful. That is what we want. Okay, so this should correctly set the bounds. We may need to step through this in the debugger to see that it's doing the right thing, but let's just try it. Daniel says, I just started learning C# yesterday after giving up 3 times before. C# is a nice language. I quite like it. Are you learning it just in the context of Godot, or like learning C# just on its own as a thing? Because I think it would be a lot easier to focus on just learning C# as its own thing and kind of separate that from learning Godot. Like what I would probably do is learn C# a little bit, learn Godot a little bit with GDScript, and then mesh them together. Because the C# integration with Godot is pretty good. But you need to know, like, you need to know C# and know how Godot works to kind of make sense of it. Okay. Nothing's crashing here, but that's fine. Where the real business is going to happen is here. Okay, we're putting this together. Nothing should be happening yet. It's when we exit from here, when we hit the back button. Let's make sure there's some stuff on the edge. We will make sure there's some stuff on that edge, some stuff on this edge, some stuff on this edge. All of the edges have a little bit of things touching them, and then we are going to exit, and that has done some weird things with where that is pivoting. That is just totally wrong. This also looks a little bit weird, like we're off. Yeah, we're like positioning them at the center rather than the correct spot. I wonder why that is. Okay, and then let's go. Did I launch this? I launched this from Godot rather than VS Code, so we have to look at it in the Godot editor. We are going to. The world is made up all of meshes. That seems good, right? So it hasn't meshed the individual voxel object voxel types together, but it has created an independent mesh for each of them. It's the same mesh. And now we want to look at the library. How can we get to the voxel library here? Voxel library, voxel types. Type number 2 is the one we just created. Can you show it to me? Okay, there we go. Voxel type, which has some solid edge faces. We have some solid edge faces. We have 500 face exclusions? That doesn't seem right. 500 of them? Oh, because we're including the 0 ones. We don't need to include the 0 ones. So that's something we can change right away. Let's go to our mesh optimizer. Face exclusions. We need to say if new face bounds, or it's not face bounds, new face exclusions. Face exclusions equals new face exclusions. Okay, we should get much less than 500 of those. And the solid edge faces, that seems like way too many. How many do we have? 94. So the way that I drew that, I think we should have had like 6 or 8. Are some of these repeats? Some of these are repeats. So how do we avoid a repeat? We're gonna need like a reverse map. I'm actually, how did we even get the repeats? Because this here should have helped with that. Oh, what's going on in chat? All that matters is that you keep coming back to it and keep trying to learn the same thing did with C with C++. Yeah, I concur. The only way to fail is to stop trying. Definitely need to keep coming back, keep giving it a shot. Okay, so if this face is an edge face, then wait, I wonder if we're forgetting to rotate something, but we're not doing anything. We're not rotating anything. Like everything's at the same orientation anyway. But we could be forgetting to rotate something. So what exactly is edge faces again? Edge faces is the edge that they are on, so we do need to rotate that. We do need to rotate that. It's not our problem here, but so we'll say edge side equals voxel type edge faces face, and we need to rotate sides. And then this get replaced with edge side. And actually, the solid sides needs to be rotated as well. Did we rotate the solid sides in here anywhere? Are we using solid sides anywhere other than here? Yeah, okay. This is all in the same voxel type, so can we get this at the top? Yes, we can. So var solid sides equals rotate sides. Voxel type solid sides, and then I think the ortho index. And this is actually probably why this is yelling at me down here, because we're not giving the ortho index. shadowing and already... Wait. Is shadowing and already existing? Oh, because we have the global solid sides. Okay, so this would be like voxel solid sides. Fine. Say voxel type solid sides, something like that. Voxel type or rotated solid sides. Voxel type solid sides. Okay, so everything's rotated. Cool. That's not actually our problem, though. We should, I guess, only generate... So each face that we think of as a face is actually two faces because these are triangles. So we should get two... we should get two faces for each position. Something's going wrong here. Just look at this data, see if we can make sense of it. So face 0 and 1 both have the same position. That's kind of expected. Face 6 and 7 have the same position. That makes no sense that these same faces, unless it's on a corner or like touching two edges at once. We need to make a simpler example to see this better. So let's quit it. We will run it again. Come into here. Make a new voxel. We're going to place something. Place something that is touching only one edge. There. So this should give us exactly exactly two edge faces, solid edge faces. So let's exit out of here and we'll place it and go look in the scene tree here from VS Code, because I remembered to actually do it from VS Code this time. Go to the builder manager, the world, which is a single mesh. How's that possible? It shouldn't be able to, or maybe it's in something else here. So inspector. It's not a lot of space VS Code is giving me here to look at this stuff. And the inspector's not working. Lame. Yeah, why is there only one mesh here? Okay, let's try the exact same thing again, but from Godot rather than VS Code. Usually the VS Code debugger works really well. So we're going to create a new voxel type with these pieces. And, place it in the world. And now we're going to go look over here. And go to the remote scene tree, the world. Okay, which has a whole bunch of meshes. That looks more like what I would expect. We need to... The world is one of our voxel object instances. That would get us to the voxel object, the voxel library. Look at the voxel types. It's the second voxel type. Come on, let me edit it. All right, and it has no solid edge faces, no face exclusions. How did we go from this creating way too many to now creating not enough? Let's go look back at the code. What did I do? What did I do? So I set this to say if new face exclusions. And it's just not evaluating as true anywhere. Something is going wrong with our bounds checking, I think. Let's set some breakpoints. So I will need to again kill this, again run it from VS Code. Ooh, I missed a whole bunch of things in chat. What's going on, folks? Only ever learned Java in high school. Yeah, Java is a very commonly used teaching language. That's almost solved. Currently in Java at uni. Yeah, Java is used a lot. As C# teacher in university. That's awesome. The clean using I mean, C# is basically Java. It's Java, but like a little bit easier to use. A lot easier to use, actually. I would say. All right, yeah, sign language. I stay away from Python for a long time. Currently learning OOP. Cool. Awesome. I guess none of your comments were targeted at me, but interesting to hear about everybody's programming learning journeys. The first programming language I ever learned was BASIC, because I'm old and my first computer was a Commodore 64. So I never learned 6502 assembly back in the day, but I know it now, and I very much enjoy coding in 6502 assembly, which is the assembly that would run on the Commodore 64. I just knew BASIC. Okay, what am I doing? Nothing useful. So we want to create some voxels here. We'll do the same test we were doing before. I didn't mean to do that. Edit you again. Well, that's interesting. I went to edit it and it's like not here. Okay, now here it is. Delete, 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 delete. Oh, okay, I meant to set a breakpoint, but apparently escape also exits out of that mode. So let's go set a breakpoint. We'll set a breakpoint at the top of the optimize method and come back into here. And then we'll go to edit this and then exit again. This triggered the optimizer again. We don't want to do that right now, though. We'll mute the breakpoints for a second. Go over here. And now when we exit out, the breakpoints are unmuted. Now we should hit the optimizer. And this is where we want to step through the debugger. Okay, we will start going through here. We only have the one voxel placement. So that position is 447. Let's look at our bounds. What is our bounds? Because I wonder if the bounds is one too many. That would kind of make sense, to be honest. So those are the locals. We need the members. Bounds. Yep, the bounds is one too many. So let's go to where we are setting the bounds, which again I think was in the palette, which is again the wrong place, but we'll work with it for now. What is happening? Okay, I got onto QWERTY again. Let's get out of QWERTY here. Okay. So this AABB, but the size we actually want is this minus vector 3, 1. Okay, so let's kill this. Let's start it up again. Yeah, we want to mute these breakpoints until we are ready for them, which will be in a moment. And now I'm going to bring up the palette so that I can jump over here, unmute these breakpoints, come back over here, and we're going to get out. Now we are in the debugger optimizing this one. Oh, this is gonna be so frustrating. Okay, what is the button to step over? F10. Because the game captures the mouse every time I advance the debugger, it moves the mouse to the center of the screen. It's really annoying. Okay, so we're going over this voxel placement, which is at 377. So this is at the front of the voxel. We would expect for the bounds mask to be only front. So let's come through here and see if that is the case. So the bounds mask is... Where's the bounds mask? What? VS Code is really letting me down today. We have some of the local variables. We do not have the bounds mask. Can I like hover over it? I know that sometimes works in VS Code. Locals, members, globals. But I'm like specifically here because I want, okay, how about this? We'll step into this method because it takes the bounds mask as an argument. Where are we? I stepped into, but I didn't go anywhere. I didn't go anywhere. Okay. VS Code, you're a disappointment this morning. Oh my gosh, we're getting low on time. How are we gonna do this? I guess I'm going to go to script, mesh optimizer, set the same breakpoint, but in the Godot editor. That is here. Let's set up the same situation for like the 5th time. This is why I was thinking maybe we needed unit tests. Oh, and there's no muting of breakpoints in Godot, so we have to... And bring up the palette. Come over here, set the breakpoint. And then we need to exit out of here. And let's start going through. I always get confused on what step over and step into is in Godot's icons, but here we go. Want to know what the bounds mask is. The bounds mask is 0. That doesn't seem right. Or wait, we haven't done it yet. Okay, let's step over. We'll do step over and bounds mask. Bounds mask. Bounds mask. Where are you? Local, config, neighbors, members. Where's bounds mask? I had it for a second and that it was 0. Okay, we'll step into. Step into. We stepped in too deep. Okay, here's where we want to be. This takes the bounds mask as an argument. So bounds mask is 1. What does 1 mean? Does that mean front? That's in voxel type. It is front. Okay, so the bounds mask thing is working, at least in this limited case. Let's step through here. This is where the interesting stuff happens. We are going to step over a whole lot. So this face that we're on has an exclusion mask. They all should actually, because the primitive voxel thing has an exclusion mask for all of them. I guess the one we care about the most is the front. So let's look at exclusion mask 1. So this actually is the front. Okay, cool. So now we are checking if this and the neighbor's exclusion mask equals exclusion mask. So this should be false. We should actually go copy this face. So we copy this face. We're going to check the bounds mask, which is front, against the exclusion mask, which is front, and we should get front. New face exclusions, which means we'll add it to the parent object's face exclusions. So this face, which should be face 0, I think. Let's go look at our face exclusions. Face 0, yep, okay, that looks right. Then let's go down to the edge faces. So if this voxel type if this is an edge face, right, that's what we're determining. We get the edge side, which should still be front, because we're rotating. Edge side still is front. We're rotating it with no rotation. Okay, now here comes one of the trickier bits of binary logic here. Taking the bounds mask against the edge side against the solid sides. This should yield just front. We should get front in the end. Yep, so that was true. Send the voxel pose. All right, let's let this go. Let's let this go all the way through, and then we'll inspect in the scene tree to see if it is doing what we are thinking it should be doing. So go to the remote scene tree. The world. Welcome to the world. Voxel object. It has just the one mesh because it was able to optimize everything that we did actually put in there. The types. Here's type number 2. It has just 2 face exclusions for face 1 and 0 and 1, which is that front face for front. It has solid edge faces, so 0 and 1 are at these positions. That is correct. That is correct. It is building up the data that we want, and yeah. Wow. We have 3 minutes left on the stream. I don't think that digging deeper into this is going to make sense. Let's commit what we've got. Let's talk about what we accomplished, and then end this stream. So where am I at? I want to get into the terminal here. So let's look at what we did. We set up this new idea of edge faces, which partially replaces face exclusions, which is awesome because I originally, in my head this morning, thought we had to do that, and then I couldn't remember why. Then we went through the whole process, re-remembered why, got it in there. I guess I still don't presently actually really remember why, but I have notes in the comments which will hopefully guide me to the right place. We are running the mesh optimizer on the new voxel types that we create, putting in the optimized mesh and setting some of this metadata. That's good. Yeah, so basically, I mean, what we're doing is we're gathering up the data during the optimization process that I think we need to be able to mesh these sort of compound voxels with another compound voxel. And if we can get that working, then the meshing is done for now, right? We're not there yet, right? We've just managed to gather, I'll say, 3/4 of the data that we need. There's still one more thing, the solid sides variable. But once we have all of this data built up, I think it should be relatively easy, maybe not easy, relatively straightforward to implement the meshing of these compound types with other compound types. I hope. So let's commit this. Do we make any new files? No, we'll say one step closer to meshing voxel voxel object voxel types. We are gathering most of the needed data in Mesh Optimizer. Push that up to GitLab. Wow. Wow. To the folks who stuck through all of that, thank you so much. Thanks so much for hanging out and chatting. Man, this stuff is brain bending, and I don't know if in the end I'm gonna regret having taken such a complex, like finicky approach. Maybe I'll end up like just saying, screw all this, we're gonna mesh on this small grid and be done with it. But I do want to see this to the end, and probably by next week I will either have this totally working or have totally thrown it out. So anyway, thanks everyone. Thanks for coming. Hope you all have a good weekend. Take care. Bye-bye.